Hello everyone, myself Vijay Kulkarni. Here in this video we will understand what are quadrilaterals. Quadrilaterals are like pieces of puzzle that fit together to form the foundation of many things and many structure in our world. It can be simple and straightforward like a square or rectangle, or it can be more complex with more slanting lines like trapezium or kite. Well, be it a bridge, a building, chances are quadrilaterals are there everywhere. Each quadrilateral has its own unique set of characteristics and properties, making it helpful for solving many mathematical problems. For example, squares and rectangles, they are often used in computer graphics and design because the sides are at right angle with each other, making it helpful because the sides are at right angle with each other, and thus it is easy to manipulate the sides and angles. Well, so next time you look at a quadrilateral, whether it's a plain figure on a page or a building at a distance, think about all the magic that it does in our world. So let's get introduced to the quadrilaterals. Quadrilaterals. Well, let's first recall what is a polygon. A simple closed figure, made up of line segment, is called as polygon, right? Okay. So if I take these 3 points and if I join them, right? So this is a straight line, this is also segment, this is also a segment. Basically these are all 3 line segments. So when you close them, so this is a figure which is closed and made up of line segments. So can we call this as polygon? Yes. Why can we call this as polygon? Because it is a closed figure made up of line segment, right? So this is called as triangle, and you know it very well. I'm just telling you that this is a polygon as well, right? Okay. So what is a quadrilateral? Well, quadrilateral is a polygon which is made up of 4 sides, right? So 1, 2, 3 and 4. Well, you can draw it the way you want. What you need to do is just make sure that it's a polygon, right? What is a polygon? Simple closed curve made up of line segments. So this is one point A, this is another point B, this is C, and this is D. And if you join them, you get a segment AB, you get a segment BC, you get a CD and AD. Now this is a closed figure made up of line segments. So that's definitely a polygon because it has 4 sides. We'll be calling this as a quadrilateral. So I hope you have understood what is a quadrilateral. A polygon with 4 sides. Now let's look at the components. It has 4 vertices A, B, C and D, right? What is a vertex? The point of intersections of the 2 sides, right? AB and AD, they are intersecting at point A. So this is called as the vertex. B is a vertex, C is a vertex and D is a vertex. So it has 4 vertices and 4 sides, AB, BC, CD and AD, right? So every quadrilateral has 4 vertices, 4 sides, and now observe carefully, A and C are opposite vertices, B and D are also opposite vertices. So if you join them, what you get is diagonal. So we are going to have 1 diagonal and 2 diagonal, right? So this is a polygon made up of 4 sides. We call this as a quadrilateral. Every quadrilateral has 4 vertices, 4 sides and 2 diagonals, right? Okay. Let's now understand the different types of polygons that we can have, right? Well, polygons are categorized based on the number of parallel sides that we can have. If you categorize polygons, quadrilaterals on this basis, then it becomes very easy to understand, right? Okay, so first thing is, if you do not have any pair of parallel sides, right? So let me categorize into 3 parts. First, only one pair of what? Of parallel sides. Only one pair of parallel side. Okay, so look at this figure now. This is parallel to this side, but these two are non-parallel sides. Okay, let me say PQRS. So PQ is parallel to RS, PQ is parallel to RS, but PS is not parallel to QR, right? So it has only one pair of parallel side. Well, we call this as trapezium or trapezoid. Trapezium or trapezoid, right? Okay, let's now consider a figure where we have two pairs of parallel sides. Two pairs of parallel sides. Okay, so basically this is one pair, right, and this is a second pair. Now here these are two opposite sides and these are two opposite sides. These are parallel to each other. So if I call this as ABCD, then what we are going to have is AB parallel to CD and AD parallel to BC, right? You can see that it has got two pairs of parallel sides. Okay, such a figure is called as parallelogram. Right? Okay, and third one is called as, we are not going to have any pair of parallel sides. This is called as kite. No pair of parallel side, and this is called as kite. Okay, so is this only the definition of kite? No. In kite what we are going to have is these two sides will be equal. Okay, A, B, C, D. It means it is going to have only one pair of consecutive adjacent side. Let me explain it to you. Here, if AB is equals to BC, then BC will not be equals to CD, but CD will be equals to AD, right? It has got two pairs, only and only two pairs of equal sides, right? Here you can see that AB is equals to BC and CD equals to AD. So this is the kite. Okay, and in kite we are not going to have any pair of parallel sides, right? So let's recall it one more time. Quadrilateral, simple closed curve made up of four sides, right? If no pair of parallel sides is equal, then it means a trapezium. If you only one pair of opposite sides parallel, then it becomes a trapezium. If you have two pairs of parallel sides, then it is called as parallelogram. If no pair of parallel sides is equal, no pair of parallel sides there, it means it's a kite. And along with that, what we are going to have is there will be two pairs of congruent sides. But how is that? It would be adjacent. If AB is equals to BC, then BC will not be equals to CD, right? So this is about quadrilaterals. Well, now we are going to deal with the parallelograms in detail. Let's begin. Let's understand the properties of the parallelograms. The first thing, opposite sides are parallel and equal. Second, opposite angles are equal. Third one, adjacent angles are supplementary. And fourth one, diagonals bisect each other, right? Now from parallelogram we can have three more types of quadrilaterals. Okay, this one is a parallelogram, okay. How many types of angles quadrilaterals we can have from the parallelogram? Three types. The first one, well, if you have a parallelogram and if you make adjacent sides of it equal, then that becomes a rhombus. Okay, so it means that every rhombus is a parallelogram. So every rhombus is also going to satisfy the properties of the parallelogram. Next, if you make one angle of a parallelogram 90 degree, then that parallelogram becomes a rectangle. Okay, so again you can see that rectangle has been obtained from the parallelogram. So rectangle is also going to satisfy all the properties of the parallelogram. Third one, if you have a parallelogram and if you make all the adjacent sides equal, along with that if you make the one angle as right angle, then that parallelogram which is rhombus as well as rectangle will become a square. will become a square. So what can I say is that every square is a rectangle and rhombus. But I want to ask you, is every rhombus a parallelogram? Okay. Is every rectangle a parallelogram? And what about square? Is every square rectangle and rhombus? Try to answer this question. Think about it. Okay, so let's now revise what we have learned. What is a parallelogram? If you have a figure in which there are two pairs of opposite sides parallel, then we say that the given quadrilateral is a parallelogram. Then if you make adjacent sides of the parallelogram equal, then that becomes a rhombus. If you make one angle of a parallelogram equal, then right angle, then that becomes a rectangle. Now, if you have a parallelogram which is a rhombus as well as a rectangle, then that becomes a square. So every square is a rectangle, rhombus and a parallelogram. But obviously, every parallelogram is not going to become a rhombus, every parallelogram is not going to become a rectangle, and every parallelogram is also not going to become a square, right? I hope students, you have very well understood this. Thank you.